Proteins are polymers constructed from the same set of 20 different amino acids. The primary structure is the specific sequence of amino acids specified by the gene. In the secondary structure, portions of the protein begin to coil and fold into unique three-dimensional formations. Two kinds of secondary structure units are the alpha helix and the beta-pleated sheet. The folds and coils of the protein are the result of hydrogen bonds that occur at regular intervals. The tertiary structure is formed by interactions between side chains of various amino acids. At this stage, some proteins are complete. Other proteins incorporate multiple polypeptide subunits, creating what is known as the quaternary structure.
Enzymes enable molecules called substrates to undergo a chemical change to form new substances called products. Each enzyme acts on a specific molecule or set of molecules called substrates. Each substrate fits into an area of the enzyme called the active site. This fitting together is often compared to a lock and key mechanism. However, the enzyme changes shape a little to fit with the substrate. In the enzyme-substrate complex, the enzyme holds the substrate or substrates in a position where a reaction can occur easily. After reaction, the enzyme releases the products and can go on to carry out the same reaction again and again.
Proteins have four structural levels. The primary, chain of amino acids. Secondary is the formation of patterns within the protein. Tertiary are side chain interactions leading to the stability of single protein molecules, and quaternary is the association of multiple protein molecules or subunits. So, in uncooked foods, proteins are normally all folded up. There are an almost infinite number of possible protein structures, but the primary structure determines the final folded shape that allows a protein to perform a particular task. Change the amino acid sequence even slightly, and it might affect the structure enough to create a new protein with an entirely different function. There are different methods that can be used to break the bonds in proteins and change them from their naturally folded state, like heat or acid or force. Heating proteins increases the kinetic energy or energy of motion within them so that they start vibrating more and more intensely. The amount of heat determines the amount of motion. More heat, more motion. Eventually, if enough heat is applied, the molecular motion will cause the bonds that keep the proteins folded to break. The knots unfurl and the proteins denature, returning to their primary chain-like structure.